In this video, I am going to introduce a new branch of physics, electrostatic. Electrostatic chapter we study in standard 12 class, but in ICSE board, this chapter has been introduced in standard 9. So, before going to start electrostats, I want to explain the other different branches that are connected with electrostats. Once we know the link, हिंदी में इसको हम लोग background बोलते हैं. Once we know the background, then we can explain this topic very clearly. So, electrostats, or you can say electrostatic, electricity, magnetic effect of current, and electromagnetic induction. These four branches of physics will cover half part of physics. Electrostatic, electricity, magnetic effect of current, and electromagnetic induction are four important different branches of physics. And they are connected with each other. So let me explain what are the points that we need to understand to explain or to understand connectivity between these four big topics, big chapters. Electrostatic. Two words, electro and static. Static means rest, electro means charge. So you can see that the branch of physics, this is made up of electro and static. Static means rest and electro means charge. So the branch of physics in which we study about charges in the rest condition, in the rest position, that branch of science, that branch of physics is known as electrostatic. So, here we need to focus important features of the charge. There are some important properties of the charge, and due to these properties, this branch, electrostats, has developed a new branch of physics. So, basically, what are the important properties that we need to study in this topic? First, we should know here the entire property based on charge in rest. So, in this chapter, I will explain what is charge, units, its dimension, how can we produce charge, that is its internal part. When I will introduce this chapter, then I will teach. Or it may be possible that in this video I will explain. But before that, we need to know that in this branch we have to study charge in rest, and there are some properties of the charges, like charge is additive in nature, charge is quantized, so quantization of charge is conserved, that is conservation of charge. So there are three important properties of charge, and due to this, a new branch of physics, that is electrostatic, has developed. So when the charges are in rest, then it will produce electric field. Surrounding the charge, it has its influence, it has its property. That property we explain in terms of electric field. Very, very important. So, in this branch we have to study charge in rest, Then when charges are in rest, then what is its effect? It will produce electric field. And due to electric field, force will be experienced by another charge or the charges which are taken near another charge. So we can say that due to electric field, electric forces are produced. Just similar to gravitational field, as Earth is pulling all body towards its center, and that gravitational field is responsible for the gravitational force. In the same way, electric field is responsible for electric force, and that force is explained by Coulomb's law. That is very important law that we have to study in this chapter. After that, we need to study that how can we produce charge from one body to another body? How can we transfer charge? Charge at rest, it's okay. But if we bring another body near to it, what will happen? So here, transfer of charge, or you can say mode of transfer of charge we need to study. Mode of transfer of charges we have to study, and there are two modes. First is the conduction, that is due to touch. Similar nature of charges are produced in the that body and it can be transferred. And second is the induction. That is when the two bodies are kept at a far distance, then one body induces charge on another body. We will go in detail. After that, here when we take two equal and opposite charges at a fixed distance, then a new property will develop, a new characteristic will develop, that is called dipole. Here we study electric field due to single charge. Mind it. A single charge will produce electric force on another body. It will help in transfer of conduction. It will help conduction and induction process. But when we take two equal and opposite charge, mind it, in chemical bonding, I have explained that what is polar bond, what is dipole. The same thing here we need to explain. Dipole is a property where two equal and opposite charges are taken at a fixed distance. And when we take dipole, then we need to know electric field due to dipole. So here we have to study electric field due to two charges, equal and opposite charge. So electric field due to dipole, and here we study on axial position. First is the, and second is the on equatorial position. There are two important branches. This is very important derivation, and the questions normally asked from this part in the board exam. So you have to understand that what will happen when a single charge we take and what will happen if two equal and opposite charges are taken. Second thing that I want to explain that these all the properties are for the point charge. Point charge, no fixed dimension, no fixed state. They are just like a point. But when a body has a definite shape, it is either in the form of thin infinite rod, it is present in the form of sheet, it is present in the form of hollow sphere, it is present in the form of solid sphere. Suppose if I say that what will happen if we take such type of structure? Suppose this body has charges. What are the important property we need to focus? Suppose you have this type of infinite sheet. Then how will we produce? What are the important features that we need to focus? Suppose we have hollow sphere. Here charge is given hollow sphere. Then what are the important in the hollow sphere? Charges will come on the surface. I will explain all these things. So what will happen here? And if we take solid sphere, the entire part is solid, then how will we find electric field? So all these four properties are explained by the Gauss law. Gauss law or Gauss's theorem explains electric field due to fixed dimension. And here some rules are given, like this is the infinite sheet, this is infinite rod, this is hollow sphere, this is solid sphere. So we use Gauss law to find electric field using all these characteristics. Now, if a body has electric field, then near the charged body, if we want to bring another charge same nature, then repulsion. Unlike charge attract, like charge repel. Due to repulsion, if we want to bring another body, you can say test charge, or you can say positive charge from infinite to a given point, then there will be force of repulsion. And to go against the force of repulsion, we need to do some work, and that work is stored in the form of electric potential. So, when we are going to study electric field, if there is electric field due to single charge, there must be electric potential. Electric potential concept we use when we bring the charge, another charge in the area of a first charge. Or you can say if we bring second charge in the area of the first charge, then we need to do some work, and that work is stored in the form of energy, that is called electric potential or electric potential energy. So here the another point that we have to focus, that is electric potential. Again we have to focus electric potential due to single charge. Very important. What will happen if we take a single charge? How will we derive expression of electric potential? And second, electric potential due to dipole. That is when two equal and opposite charges are taken. Then in this case, what will be the derivation of electric potential? So, from this point, quantization, conservation of charge, electric field, Coulomb's law, then induction part, conduction part, this electric field on axial position, on equatorial position. From this portion, many questions are normally asked in the different board exam. And here, this is the long derivation, like derive an expression of electric field due to thin infinite sheet. Then hollow sphere, questions may be asked. Derive an expression of electric potential due to single charge, electric potential due to charge. Then here we will study equipotential surface. Then what will happen if potential is constant? It is not varying. And the last, we have to focus capacitor. That what is the important role of charge? To store energy, capacitor is a device which can store energy, which can store charge, and that we need to focus capacitor, its unit, its dimension, arrangement of capacitor, that two or more capacitor we take, then how they are arranged, series, parallel, mixed, derivation of or designing of capacitor, parallel plate capacitor, spherical capacitor. So all these information we need to focus in this branch, electrostatic, and the most important branch of this part is, I think, dipole. From dipole, it is very important part. Gauss's law, capacitor, all these important branches, you will get long answer. And these branches like quantization, conservation, this conduction, induction, from these topics, you will get either short questions or numericals. So, I will explain all these things in detail, that what is quantization, what is additive, what is conservation of charge, how can you transfer charge by conduction process or by induction process, what is dipole, how to find electric field due to dipole on axial position and equatorial position, what is electric potential, how we apply Gauss's law, what are the important points that we have to focus to study Gauss law. That is very, very important. I will explain when I will start this chapter. Second branch of physics is electricity. Electricity, its another name is current, flow of charge. So here we have taken charge in the rest. Here we made charge to flow. Very, very important. Flow of charge. And when we flow charge, then with respect to time. When we are flowing charge, then we are comparing time. So rate of flow of charge is called electricity. So what is difference between electrostatic and electricity? In electrostats, we keep charges in the rest position. But in electricity, what we do? We take charges in motion. And due to motion, different properties you will get. Now you just imagine that what will happen if charge will flow. When charge will flow, then some obstruction must be produced in the charge. The first thing, why charge will flow? So we can say that charge will flow due to, we can say flow of electron will reduce flow of charges, flow of electricity. Electricity will flow opposite to the flow of electrons. So I will explain this drift velocity. What is drift velocity? How will we drift the charges? So when you suppose you have taken charge, then if you have taken a device, from that device you made flow of charges. For this we need battery or shell. That shell or battery will produce EMF, electromotive force. That electromotive force, due to this electromotive force, charges will move positive and negative charges in opposite direction, and due to this potential difference, mind it, here we have already studied what is electric potential. It is a work. When we bring a charge from one point to another point, we need to do some work. And that work is stored in the form of potential. So here when we apply a battery or shell, then charges, suppose it has positive and negative charges. Suppose like this. So this is positive plate, this is negative plate. So this becomes positive, this becomes negative. So here positive will person, positive will move this side, negative will move side. So this zone negative, this is entirely negative, and this entire will be positive. So here will be high potential, and here will be low potential. And due to potential difference, flow of charge will start. Due to temperature difference, heat will start. Similarly, due to potential difference, current or electricity will start. Flow of charge will start in a given time. So we can say that here first is we need to design what is electromotive force, what is the potential differences, that we have to focus. Second good properties, that when charges will flow, then what will happen? Obstruction will be produced in the charges. There are some internal property that will oppose flow of charge, and that is called resistance. Resistance. To oppose flow of electricity, oppose flow of charge. And combination of resistance. How will we connect resistance to reduce charge? Sorry, how will you connect resistance to reduce resistance? Either series or parallel or mixed. So how can we maximize resistance? Because resistance is inversely proportional to current. I will explain all these things. Ohm's law. What is Ohm's law? So when resistance is there, current will is inversely proportional. Because more resistance, less current will flow. So here everything depends upon resistance. If we minimize resistance, flow of electricity will increase. If we maximize resistance, flow of electricity will reduce. So you can say that resistance will affect flow of electricity. So there is one most important point that we need to focus in this branch, that is combination of resistance. And in this branch, we have to study combination of resistance in 3 mode: series, parallel and mixed. One thing I want to explain, that Here in capacitor, we will arrange different capacitors, series connection, parallel connection, and resistance also we do series parallel. So the calculation method of capacitance is opposite to resistance, that I will explain how it is. But you just know, in this video you just know that what we are going to study in electricity, what we are going in electrostat, and how they are connected, what we are going to study magnetic effect of current, electromagnetic induction. So combination of resistance we will study, drift velocity we will study, relationship between drift velocity, then relationship, or you can say Ohm's law, derivation of Ohm's law. After that, here two laws are very important that will explain, just like Gauss's theorem. Here we also study two different laws like Kirchhoff's law. When we take group of resistance, then Kirchhoff's Wheatstone bridge. To design combination of resistance, this is the important part, because from this part we will get question in the board exam, 5 marks. Kirchhoff's law, then potentiometer to study flow of electricity part. So here two big derivation, that is derivation part is, first is the Kirchhoff's law, second is the and Wheatstone bridge. Wheatstone bridge. Then when this bridge becomes balanced, that we need to study. And second is the potentiometer. It is a very important device, potentiometer. We have to focus. After that, we have to start magnetic effect of current, and the scientist who is responsible for the introduction of this branch, Othr. He did an experiment. I'm just showing the relationship. Once you understand the link, you can explain that electricity. Charges are taking in motion. So what are the important property that we need to focus? Electrostat, charge in rest. What are the important property that we need to focus? Here, Othr observed that he took a wire having battery or shell, and he observed that he took a magnetic compass and he observed that when uniform electricity is flowing through a wire, then this magnetic compass does not show any changes. But when change of electricity is flowing through a wire, he observed that this north pole is shifted towards the wire side, and this moves this side. He was shocked. What will happen? Here, current is flowing and this magnetic compass is circling. There is no magnetic field. So how will current be responsible for the changing of direction of magnetic compass? What he did? He reversed the direction of current. He reversed the direction of current, and he observed that after reversing, the direction movement of magnetic compass changed. Then he said that our magnetic material will produce magnetic field is okay, but when a current is flowing through a wire, then that current will also produce magnetic field. That's why its name is magnetic effect of current. So you cannot say that only magnetic compass will attract or repel. Whenever changing magnetic field, changing electric field is there, then magnetic field will produce, and that magnetic field will show magnetic property, attraction, repulsion, all the magnetic property that we observe in magnet. So he introduced a new branch of physics, magnetic effect of current, that is production of magnetic field due to changing electric field. So if there is no electricity, then in this word you can say magnet can produce magnetic field, but if current is flowing through a wire, that wire will also produce magnetic field and the entire wire will produce magnetic effect. So Oersted law is very important in this part. Oersted experiment we need to study. After that, here what is the electric field produced? What is the electric force? For this we use Biot-Savart's law. Very important. There are some important laws that we need to focus. Ampere-Salpeter's law. Very important. Lorentz force. And torque produced in a current carrying coil. Torque produced in a current carrying coil. This is linked. When you have to find magnetic field due to long wire, due to circular coil, circular loop, then we applied Biot-Savart's law. That is magnetic field, small magnetic field. This law is responsible for production of small magnetic field. It is mu naught 4 pi I dl sin theta by r square. I will explain all this thing in detail. But I am just giving you some tip. Students get confused that when all this law, when we will apply. This is very important point. In competition, you get maximum question from this part. So, Biot-Savart's law to find magnetic field due to long infinite wire, or you can say circular coil, or you can say circular loop. If you have to find solenoid and toroid, then you have to use this Ampere-Salpeter. Very important. If you have to study cyclotron, in cyclotron we have to study Lorentz force. Lorentz force is the combined force of magnetic and electric field. When there is a magnetic field and electric field, then its combined effect is called Lorentz force. So here cyclotron part we have to focus in this branch. Torque produced in a current carrying coil is responsible. What is torque? That we have also studied in this part. When dipole is taken, then torque will produce. So torque producing current carrying coil, we need to focus. That derivation will help moving coil galvanometer. Mind it, galvanometer is a device which gives signal that is current is flowing or not. Flow of current. Flow of current signal is given by galvanometer. So when we understand the concept of torque produced in a current coil, then we can explain galvanometer. When we study Lorentz force, then we can explain cyclotron. When we study Ampere-Salpeter law, then we will study about what? Solenoids and toroids. And when we study Biot-Savart law, we can explain magnetic field due to straight wire, coil and loop. So we need to focus these 4 laws, 4 characteristics that will help to derive the entire derivation part. And the last is electromagnetic induction. This branch is fully opposite to magnetic effect of current. Here current is producing magnetic field. In electromagnetic induction, changing magnetic field will induce current in a coil. And the scientists The name of the scientist who is responsible, that is Faraday. Very, very important. So, one thing I want to remind you, I want to explain you that Faraday's observer, he took a bar magnet and he took a coil having galvanometer. Galvanometer is a very, very important device which is used to show flow of electricity. Whereas ammeter is a device which can measure current, electricity. So he took a galvanometer, no battery, no EMF, and he observed that when both are in the rest condition, there is no production of current, no electricity. In the second experiment, what he did, he started to move this bar magnet towards the coil, and he observed that when bar magnet was moving here, then current will start to flow in anti-clockwise direction. Very, very important information he observed that here when bar magnet is moving, then current will flow in the opposite direction. In the third experiment, what he did? He moved bar magnet away from the coil. Here bar magnet with the north face is moving towards the coil. Here bar magnet with the north face moving away from the coil. What he observed that here clockwise direction of flow of current is. In third experiment, he changed the nature. Here south, here north, here south, here north. He observed some properties. On the basis of properties, he observed that this magnet, we know that magnet produces magnetic field. So this magnetic field is changing. Due to changing magnetic field, an EMF is induced in the coil. That is called induced EMF, and due to induced EMF, electricity will produce, and that is called ED current. Very, very important information that whenever a current carrying coil or a bar magnet is taken near another coil, there is no battery, no cell, there is only single galvanometer. Then what will happen? Magnetic field will change. Due to changing of magnetic field, flux will be produced here, magnetic flux. And that magnetic flux will produce an EMF in the coil, that is induced EMF. When this EMF is induced in the same coil where current is flowing, this is called self-induction. And when this EMF is producing in another coil, this is called another mutual induction. So there are two branches of induction, self-induction and mutual induction, that we need to study in this branch. And as there is an EMF, as there is electromotive force, current will produce, and that current will be called ED current. And the direction of current, that was explained by Lenz law. Here it was the Lenz who explained what will be the direction, whether anti-clockwise or clockwise. When I will start this topic, then I will explain that what is electromagnetic induction, Faraday's law, then magnetic flux, then what is self-induction, what is mutual induction, what is ED current, what is derivation related with this topic, electromagnetic induction. So you are observing that a single charge is playing different role. When charges are taken in the rest, it will show different property. When charges are taken in motion, it will start electricity, and when charges with very electric field is there, it will produce magnetism, and when a magnetic field, that is very magnetic field, is taken near another coil or in the same coil, what will happen? Another property will develop, that is electricity will produce. So you can see that a single charge in rest will produce electric field, flow of charge will produce electricity, very electric field will produce magnetic field, and very magnetic field will produce electricity. So these four branches are very important. So in the next video, I will explain what is electrostatic. I will go in detail, and whenever I will take this class or I will introduce this topic, I will introduce questions first. For example, what is charge? SI unit of charge. What are the properties of the charges? Like this I will explain, so that those students who are preparing for their boards, they will be comfortable, they will understand what type of questions can be asked in different board exam. Thank you.